Thanks for joining, and welcome to my talk on the 5 sins of data observability. Let me first start by introducing myself. I'm a software engineer converted to data, and I started initially in open source, built some open source community. Really, like that drives me is building, connecting people together, building some code and sharing it with everyone else, and then creating a community around it. I did that first, build my own open source project, then joined JBoss, and that's how I entered into Red Hat as well. So open source is really like a core theme of what I've been doing. Love it. Then also the other part of what I've been doing is languages, which are kind of like low code languages that allow like less technical people to participate in the automation process, so that you don't always need the engineers to do like full software engineering. And these low code solutions then help to scale, to involve more people with things like shadow IT. It's like BPMN is an example in the workflow space that I've been doing in the past. And nowadays I'm doing similar things in the data space that I'm going to talk about. And as I was fascinated by data, I want to give you a little bit of a perspective of how that feels for me. So first, consider this. Like, the collective human intelligence is only limited by what an average human can learn in a single lifetime. Right? If you take that as a starting point, and then look at the last 300,000 years that Homo sapiens has been around. So for the most time, there was only oral communication to pass knowledge around. And then only like 600 years ago, we invented book printing to speed up that process a bit. 25 years ago, we had computers and internet popping up. And now we have Wikipedia and Google. So that has put the knowledge passing on steroids. So for the fascinating part now, which is machine learning and data, that's the next frontier. Because with those two ingredients, we can now start learning beyond our human capacity. So and that may sound a bit like science fiction and over the top, but actually it's already happening, because brain tumors are being detected better by computers than by humans at the moment. So and that's really my motivation to go into data. I think this is the place to be, where in software things are happening right now. And that was my starting point to co-found Soda, where I'm now the CTO. So as you grow up, you often do things you shouldn't do. And in analytics and data observability in particular, that's also growing up. And so I will walk you through some of the things that are considered sins and that you shouldn't do in data observability, so to help you on your way in that journey. But before, I want to start with a bit of an overview to get a perspective of the landscape. Analytics data is the place where all the information from a company is combined, mingled, and prepared for data applications. All the way at the right, you see the data applications. An example of that could be calculation of hotel prices, of hotel room prices. So each night there is an algorithm that uses the most recent data and computes the new hotel room prices. And other examples might be recommendation engines and business intelligence reports. And all the way at the left, you see the source data, which typically are coming from the internal systems in companies, and then could also be externally purchased data as well. The data pipelines, they actually do the crunching from left to right, and they combine all this data into processing jobs. It might be like software that is combining the data, but also could be just like SQL select statements could also be part of transforming that source data towards the data products. And the data products are considered that like tables. If you're a software engineer, then think of this as tables, but in the analytics world, we have a fancy name for that, which is called a data set. But you can think of it as a table, basically, as a software engineer. So, and those data sets, the data products, they contain the most recent data that are then being used by the data products. And so what's important if you have a software engineering background, not too familiar with analytics, it's important to notice here that the flow from left to right is kind of constant, right? So it's continuously, either in batches, daily batches is very common, daily batches that the data is munched and crunched and then enters into those data products. We see also more streaming popping up so that there's less of a delay, so that the data in the data products being consumed in the applications is kind of nearly real time, but it's still very small proportion today. Okay, now you could consider this is all great. Like we have our constant flow of data products are running, all good. We can go to the bar and zip from some fancy cocktails, but we're not there quite yet. So, because that's your first sin right there, which is unrealistic optimism. In reality, a lot of things can go wrong. And the data may change in your source system. And this is typically a problem because the teams are disconnected. If an operational, like in Salesforce, someone does a change there, they don't always notice the analytics teams that are using this data. So that just these kind of changes happen. Bugs in data pipelines, they happen. And so trying to prevent data issues is a no-go. Well, you can try it, but you won't succeed. So preventing data issues is impossible. So damn, that's a problem. And remember the hotel prices algorithm, right? If we cannot rely on the data being correct, we actually have a huge risk from a business perspective because our revenue is going to be bad either way if the prices of our hotel rooms is bad. So this is a huge risk. So you can imagine that this is bad for business. And it gets worse because unlike software bugs, data issues, they are most often silent. Data applications, they just keep crunching. That software, like if the data is bad, doesn't matter. Software keeps crunching and the only difference is that the results are wrong, but there's no crashing involved. So the data issues don't cause crashes, like software bugs do. At least it crashes, and then you know, like this is not working. So every data team can confirm that data issues, they occur regularly, and the only protection that you can do is start putting data monitoring in place. And before diving into the monitoring, just to give you some concrete idea of what we're talking about, these are some example data issues, right? So a column in a table just disappears out of nowhere. For instance, in the orders data set, there's a column called customer category, and suddenly all the values for country Sweden are null. If you then have a report that's based on that, you're screwed. And another example is like 25 duplicates in the approval row. It's like all these kinds of typical things that can go wrong in the data set. They happen all the time. Now, data quality is all about building trust in the data that flows into your data applications. And data quality here is like the umbrella term. I used observability in the title, but you should consider data quality as the umbrella term under which you will find data observability, data reliability, data testing. And the differences between all of those are luckily not important for this talk, as the data industry itself is still trying to figure out the exact meaning and trying to agree on it. So, and in order to find these data issues proactively, we're going to put monitoring in practice, and there's like two main strategies that I want you to be aware of as you leave this talk. Because one is based on machine learning. That means like you're going to look at the data and then figure out, like let the machine learning figure out what normal data is. And once it knows that, it can flag when there's abnormal data. So that's like a good strategy because it doesn't require a lot of setup. Just like an empty box, you wait a bit and the machine starts learning. That's good. But relying a bit on machine learning only too much is kind of dangerous because it can get noisy. Fully automated solutions, they only have one sensitivity knob. So if you turn it too loose, then you will miss important data issues. And if you turn it too sensitive, you get way too many alerts. So that's the danger right there. And the other strategy is to get people involved into writing checks. These are the expectations of your data. And so having people to write checks is, yes, that's more work, right? You have to put in that knowledge that people have in terms of that data. But people have the domain knowledge. They can tell you things like, for customers in their notice period, no discounts are allowed for products X, Y, and Z. Those kind of things are, machine learning will not start to fetch that out of the data automatically. And it goes like much more fine-grained than that as well. And this is similar to test-driven development. These explicit checks is a very clear analogy there. And in software, no one actually thinks about skipping building the test suites. That's normal. You don't rely only on your New Relic and Datadog monitoring in production to have trust in your software. No, you also write test suites that validate for each new release that you can trust it. So the second sin here is to try and exclude the people and only rely on the machine learning. And so, of course, that sounds like an open door coming from the engineering background, as I just mentioned, right? Okay. With this background, we can turn to one of the big pitfalls that you can get into as you're getting started with data reliability, data observability, and that's alert fatigue. Alert fatigue is a very real danger in data monitoring systems, and both monitoring strategies, both machine learning and the human, both lead to alert fatigue, but the machine learning algorithms are a bit more prone to suffer from this problem than handwritten checks, as they have much better signal to noise ratio. And alert fatigue means that people will zone out. And there's two main reasons to that. Is when there's like far too many alerts to process, and if your list grows endlessly, there's no motivation to start doing the first three. And the second one is that you don't know how to handle it. If you if you have a list of 10 items, you digest the first, you don't know what to do with it. The second one, after the third one, you give up. So these are two important considerations as we will be tackling them next on how, giving two aspects on how to tackle these alert fatigue. So let's patch alert fatigue. So first of all, all right. So the first is have people write checks. That's the first way on how to ensure. Again, maybe a bit of repetition here, but only relying on machine learning will get you much more alerts, and that will lead to much more alert fatigue. So, and then in terms of people writing checks, there's like different types of people. There's like hardcore engineers that do publishing of software. There's the analysts. Those are the mathematicians that have the mathematical background of turning all that data into the data sets into useful things. So if you want that price algorithm, how are you going to compute that, right? That's the analyst's job. And they have certain expectations of the data as well. And then there's like the data owners, those that take responsibility to publish a certain data set. So all of these different types of people, and we'll dive into that a bit more, they all need to be able to participate into writing these checks. And secondly, ensuring good workflows. I didn't touch on that yet, but that comes from data management experience. And that discipline has basically a longer history and track record than the big data boom. It happened way before that. And there's like processes and workflows involved to making sure that this data issue resolution workflow keeps running at scale. And that must those workflows work. To make those work, you need to make sure that tooling supports the whole flow of like diagnosing the alerts, triaging false and unimportant alerts, and fixing the root cause, and then marking an issue as resolved. So all of that like seems like very basic steps, but making sure that your tooling supports this will ensure that people don't give up and that you can have a sustainable workflow to drive this. Okay, so let's look, how does this look in practice, right? I want to give you an idea of what it means to write these data checks and protect your data applications. So this is a language that we've called SODA checks language, or SODA CL. And you can see there are some basic checks for missing data, for invalid data. There's some schema checks, referential integrity checks, and many more. At the end of the presentation, I'll give you a pointer to find out more, because there's like many more types of checks that we have in there as well. And this is what you can consider the counterpart of test-driven development in data. So the next sin is make sure you don't postpone writing these checks. Because as an engineer, when you're building your next pipeline or transformation, as a data owner, you publish at a certain point your next data product. And as an analyst, when you're in the midst of consuming this data, that's when you have full context of what you're expecting from the data. It's the same as writing software. When you're totally into the zone of writing the code, that's the best time to write your unit tests, because you know how the different aspects need to be covered. Same here. So yeah, don't postpone those checks. Make sure that you write them whenever you are, whenever you're dealing with the data. Then all those aspects that you're dealing with have to be covered. And those also come, like the aspects, like the different people typically have different aspects. As an engineer, you might rely, your data pipeline might rely on a join, which might rely on the fact that this other referential data is unique, for instance. So those kind of checks would be embedded by an engineer, whereas an analyst might, with a machine learning model, might rely on the fact that the distribution has to be normal. Okay, so when you have this language that describes the checks, there's two very important styles of how you're going to run these checks on your data. And one is preferred by engineers. That's the embeddable style, where a library is the best approach, which you can then straight put into your data pipelines. You embed it right in there. You want to manage that artifact, those files that contain the checks as code, and with your code, put it into your Git repository and have a deployment process around it so that you have full control of what is run and where it's run. The second approach is web-based. And this is also kind of important because it's really needed for the less technical people. So analysts and data owners, they need a web-based environment where they can write their checks and do a full testing cycle as well there, so that we send the checks to the data, run them there, get the feedback back, just like in an IDE for developers, but then for the simpler language. And that's when you have the low-code approach working. And this self-serve is quite important to involve those people, because a lot, like in the past, a lot of the checks, the process was that analysts knew what had to be checked. They tried to pass it to the engineers for them to code the checks in their pipelines and then have this system running, but that just doesn't scale. So if you cannot make it self-serve, all the domain knowledge of those people is lost. So that's why this is actually a crucial deployment style as well. And in this case, analysts, of course, are not too involved with where does it run, how does it run, is it scalable, it just needs to work. Right. So that's another sin there, is to have no open source and no embedded capabilities, right? So I touched on that a bit. Like, as an engineer, you want this file to run straight into your Airflow, which is the way to build your pipelines in your prefect or in your Python or Docker environment. And as you're building, as an engineer, embedding this into your pipeline, it's important, as I mentioned, that you can run or manage them as code and also stop the pipeline if needed, so that you run these checks and afterwards you can actually access the results. Are there any failures? Are there any warnings? And decide on that whether the pipeline should be stopped, which is also referred to as quarantining the data, making sure that this data doesn't flow through so that your algorithm doesn't start running and then producing bad data or bad outcome like the hotel environment. And another sin is, of course, avoiding the self-serve. This is quite crucial. So as I mentioned, this enables the less technical people with self-serve. Authoring environment is important. And if you don't have this self-serve, that means you're going to skip all the that you're going to skip all of this knowledge being checked, basically. Right. The next part is, and like this. Right. That was the part I was looking for. In self-serve, you should see this as the next revolution in data, because what happened to business intelligence, right, is happening on the data quality space right now. In business intelligence, imagine the days when whenever you needed a new report by the business, you had to go to IT and they would actually compile this report, and it took like for ages for this report to be done, and by the time it was done, it was either deprecated or you wanted to change or your ideas have changed. And so there it already happened. Business intelligence now is self-serve, and this has been like a drastic shift in getting the data to use properly. And so that is exactly what we see happening now and what we're aiming for with our tools. And you have the language, right, that describes the checks. And this is the basis of what we see also as the next frontier in data observability and data quality, which is data contracts. Data contracts comes from a work done by Degami, and it's called data mesh. And this is similar to what service-oriented architecture and microservices were to software, making sure that you build small services that do one thing well and that communicate, work very good together. This is exactly the same thing. We come in the data space from a situation where you have like long spaghetti pipelines, all interconnected, no communication. It's very hard to distill if something goes wrong, like where is this problem coming from? And the data mesh introduces the notion that like all the teams should operate as independent teams, and if a data set is shared between teams, pay very close attention to the handover. Whereas you have an API contract in software, where like REST APIs put like a very technology-driven way of communicating. This is what you can expect. Data contracts are the same thing for data and analytics teams as they work together. And so SodaCL for us is the basis of those data contracts. So that's the similarity there. Now, just wrapping up, there's like, I just wanted to sketch like these 4 pillars, or like the pyramid, and how it's stacked up on how do you build up the picture of what good data looks like, right? It starts up at the bottom with an easy jump start. You have a data platform and you want some component to be installed there as your data quality service in a data platform. And of course, the people that do this, the data platform team, they don't know all the data. They just provide the infrastructure. So the tool should be able to just be installed on your data as a service. And there might be some machine learning going on that does some very low-level basics as to tracking all the row counts so that you can find out if like one row count drops to 0 or something like that. That's on the lowest level. And of course, you're going to get a lot of noise if you do that too much. And there's the reliability checks that are typically added by the engineers building the pipelines. This has to be managed as code and embedded into the pipelines. And then on top of that, you have analysts and data owners that can start contributing your checks and data contracts. And that's where you get a lot more signal to noise ratio if you roll out a strategy based on this. So in summary, keeping trust in your data is non-trivial, right? Monitoring is really needed, and you need to look at a combination of machine learning plus people to build up that picture of what good data looks like, and make sure that like everyone can participate, because the different types of people have different needs as to embedding certain checks into your pipeline versus having a self-service environment where you can contribute those checks. And then like data contracts is really important to split up the handovers between the different teams and to create clarity on what's expected. So, and with that, I think you're all ready to get going. So I hope to see you in our community. So we have an open source project as part of our offerings. And that's where you can learn from each other, just have a chat. And given it's open source, you can just try it out as well. So I invite you to write your first check today. So with that, thank you very much. Any questions? Seem to went faster than I thought, so I have plenty of time.
Yeah, thank you so much. Great talk. I love when you talk about the data engineers at the lower level in the pyramid contributing checks versus people that maybe have more domain knowledge contributing checks at a higher level. What I've found, being more from the lower levels in the teams I've worked in, is when and how to get the checks from upper level down into the lower level. Because I assume, imagine the analysts do find some problems in upper level. After a while, it would make sense to incorporate that into earlier stage in the pipeline, so to speak. And I've never really found a good process in that. There's always a disconnect between the domain experts and maybe the ones doing the pipelines, for instance. I don't know what your thoughts are.
Yeah, so I think like the question is like, there's different types of checks between like the engineers start off with some checks, then as the data gets used and the analysts and other people have more ideas about this, like where should they add those checks? And it's not necessarily that those checks come later. So for instance, as an engineer, and this is something where we don't have like very prescribed patterns that everyone knows and follows, and it depends a lot on every organization has their own wish as to where do they want those checks to be applied. But what we've made sure is that if, as an engineer, you decide this is where we want to run our checks, like really early in the pipeline, then you can connect that even to the checks that are being written in the platform. So we're quite flexible as to where you want to run these checks. But in general, you should look at it as an engineer, you decide where you apply the checks, and then you can consider the cloud platform as something that produces a set of files which are just fetched by what we call a scan, which is like running a set of checks on a given data source. Yep. Oh. Oh. You're welcome. That does me a lot of pleasure to hear that. No. So if you haven't done your taxonomy and like dive into a little bit deeper, can you still start? And the answer is, of course, you can. It's the same with test-driven development. It's like the first thing you need to do, like you can't start if you didn't select yet a testing framework. So that's the first thing. Install a testing framework so that you can write your checks if you want to. And then start small, wherever you think about like this It's something that gradually builds up, just like a test suite. As you're writing the code, you write some unit tests, but as bugs come in, you enrich that test suite with all the cases that you didn't think of testing right before. And this is the same with data. So the first one that touches a certain data set might be the engineer that actually creates for the first time a new data set because of the request of an analyst that's built a new product. And as the engineer builds it, it can start with a couple of basic checks, so that when you have this in place, when the next one comes around and considers this data and adds their expectations to it, then it gradually builds up over time. So you can just start very small. You don't need anything to get started, except consider like, how does this build? How do I put the infrastructure in place so that I can start writing checks when I want to, and then start small.
First of all, thanks, Tom.
Thanks.
I have a question about where you want to put the checks. I have a feeling that maybe you could also bring the main experts to the lower level team and have them collaborate on the checks on the lower level. Because when you notice a problem, someone has to fix it as well. Maybe the analysts or the main experts don't have that capability.
Gotcha.
And then it becomes, you have to wait to communicate.
Yes. So let me see if I can start giving an answer. The question was, where do you want to put those checks, right? And if you look at the whole data and analytics landscape, you have your source data and you had your data products that went into the application. So the data products are considered like the refined data or the data ready to go. That's your ultimate integration test. That's where you test everything that comes before, where you can really know like, this is the data that's actually being used. So that's your last place where you can test, and that's the first thing you want to do. It's like, that's the basis. And then everything that comes before that, because that would be the first thing that I write, like put your checks there. And you can actually duplicate a lot of the checks on the source data. On the source data would be number 2 where I put it. Because that already, like all the other tests, the checks on the data applications, they protect your, all the way your usage, right? And the checks, the next one is on your source data, because that distinguishes between all of the problems that happen at the source versus the ones in your pipelines. So then as an engineer, you already know, like, if at the end something fails, then we can start looking at the source data checks. It's like, should I look into my Salesforce or should I look into my Salesforce data pipelines? And then you can gradually put more checks in the intermediate stages to help the debugging process as to finding where exactly is this process or is this problem. And I would have the teams, because often in larger organizations, you have distinct teams that rely on each other's data. And those team boundaries, I would actually put the checks on that, because if you already can identify it's going to be in this team's data set, then they will be able to figure out in their own internal systems in more detail as to what was going wrong. They can like have maybe like a testing environment set up where they can figure out how this problem came about, or have more checks left and right. But with that, not sure if that answered the question you had. Okay. No more questions? Then I think we can start our 4 o'clock break, and we can start eating all the waffles, and then we're done. Thanks a lot.